Have you ever looked up at the night sky and thought it's a little clumpy? It turns out you're not wrong. The universe isn't a random spray of stars and galaxies, it's organized. But the reason why is one of the biggest cosmic jokes ever played on us. Imagine trying to build a giant, glittering city, but you only have enough bricks to make a few small houses. That's the puzzle astronomers faced. We looked out and saw magnificent superclusters of galaxies, stretching for hundreds of millions of light years. The universe looks like a cosmic spiderweb, shimmering with galaxies caught in its threads. It's beautiful, it's grand, and it shouldn't be there. The problem was gravity. We know gravity pulls things together. It's the ultimate cosmic contractor. Give it enough time and it will build magnificent structures. But when we did the math using only the matter we can see, the stars, the gas, the dust, all the shiny stuff, it just didn't add up. The universe is 13.8 billion years old. That sounds like a long time, but for gravity to build the enormous web we observe today, it would need a lot more time or a lot more stuff. It was like watching a master painter create a breathtaking masterpiece with an almost empty paint palette. The picture was there, but the artist seemed to be using invisible colors. This cosmic puzzle pointed to a profound and humbling conclusion. Most of the universe is missing, or rather we were missing it. The answer lies back in the baby pictures of the universe. I'm talking about the cosmic microwave background, or CMB. This is the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. This ancient light isn't perfectly smooth. It has tiny temperature differences, minuscule hot and cold spots. These spots represent areas where matter was just a little bit denser, or a little less dense. These were the seeds of all future structures. But here's the catch. These initial density ripples were incredibly small. Imagine a nearly perfectly calm ocean, with waves less than a millimeter high. Now try to get those tiny ripples to grow into towering tsunamis in a limited amount of time. That's the challenge gravity faced. The pressure from the intense light and heat in the early universe pushed back against gravity's pull on normal matter. It was a cosmic tug-of-war, and gravity wasn't strong enough on its own to win. This is where dark matter enters the story, not as a bit player, but as the hero. Dark matter is the universe's secret ingredient. It doesn't interact with light or radiation. It feels gravity, and that's about it. So while normal matter was stuck in that cosmic tug-of-war with light, dark matter was free to act. Think of it like this. Dark matter built the scaffolding first. It created deep gravitational wells or potholes all across the cosmos. Then, once the universe cooled down enough for normal matter to be released from the grip of light, it began to fall into these pre-dug wells. How can we be so sure about this invisible architect? We can't just point a telescope and see dark matter. So, scientists did the next best thing. They built their own universes inside supercomputers. These are cosmic simulations, some of the most complex and ambitious computer models ever created. Projects like the Millennium simulation and more recently the Illustris TNG project are our virtual laboratories for cosmology. These simulations start with the known ingredients of the universe, based on our observations of the cosmic microwave background. They plug in the laws of physics, like gravity, and then they add the matter. First, they tried running the simulation with only the matter we can see. They pressed play and watched the universe evolve for 13.8 billion virtual years. The result was a cosmic failure. Then they ran the simulation again. This time they added the missing ingredient. They programmed in a huge amount of cold, slow-moving dark matter, about 5 times more than all the visible matter combined. This time, when they hit play, something magical happened. The dark matter began to clump together almost immediately, forming long, intricate filaments and massive halos. The result was breathtaking. The simulated universe looked almost exactly like the real one. It had the same web-like structure, the same massive galaxy clusters at the nodes, the same long filaments of galaxies, and the same vast, empty voids in between. It was the ultimate proof of concept. The only way to build a universe that looks like our own is to use dark matter as the primary building material. Simulations are powerful, but they are just models. To truly prove the existence of this cosmic web, we need to see it in the real universe. But how do you observe a structure made of something invisible? The answer is by watching how its immense gravity affects the things we can actually see. One of the most spectacular ways we do this is through gravitational lensing. According to Einstein's theory of general relativity, massive objects bend the fabric of space-time and light follows these curves. So, a massive object, like a cluster of galaxies, can act like a giant magnifying glass in space. When we look at a distant galaxy behind a massive cluster, we see stretched out arcs, multiple images, or even a complete ring of light, known as an Einstein ring. The amazing part is that the amount of distortion we see is far too great to be caused by the visible matter in the cluster alone. But when we calculate the mass needed to create the lensing effect we observe, it perfectly matches the amount of dark matter predicted by our simulations. Another powerful tool we use is galaxy redshift surveys. By measuring the redshifts of hundreds of thousands of galaxies, we can create a three-dimensional map of their positions in the universe. Projects like the Sloan Digital Sky Survey have done exactly this, painstakingly mapping the cosmos, one galaxy at a time. The result is not a simulation but a direct observation of the universe's structure. And what does this map show? You guessed it, a giant, glorious cosmic web. This real, observed map is a stunning confirmation of what the dark matter simulations predicted. So, what if we're wrong? What if there were no dark matter? The universe would be a far more boring place. Instead of a rich tapestry of galaxy superclusters, we would have a sparse cosmos with small, underdeveloped galaxies. There would be no grand web, no magnificent filaments, and perhaps no Milky Way as we know it. Life, if it existed at all, would have had a much harder time finding a stable home. The cosmic web is more than just a pretty structure. It's a testament to the power of the unseen. Every galaxy cluster we see, every filament of light is a brushstroke made possible by an invisible artist. This structure tells a story of cosmic construction on the grandest scale imaginable, a story where the main character remains hidden in the shadows, revealing its presence only through its profound influence on the stage. When you look up at the night sky, remember what you're really seeing. You're not just looking at stars, you are looking at the glittering decorations on an invisible cosmic scaffold. Each point of light is a clue, a breadcrumb leading back to the ghost in the machine. It's an invitation to appreciate the profound mystery that binds the cosmos together. If this cosmic journey expanded your mind, help us expand our reach. Don't just hit subscribe, forge a new neural pathway and make it a habit. Share this with someone whose universe needs a little shaking up, and light up that like button like a supernova because every click helps us map the unknown. Keep looking up.